Hello, Namaste, welcome to this channel Chemistry Made Easy by Dr. Ashok Mulik. Today we will see the next point in this above principle. So this is also a part of our topic atomic structure. So last time we have seen the various rules which are coming under the above principle, that is Pauli's exclusion principle, then Ohm's rule of maximum multiplicity, etc. Now we have to see another rule that is called Schleskowsky rule. That is Schleskowsky rule. So this rule states that atomic orbitals which are lower in energy are filled first. So the building up of the atomic orbitals with electrons begins with lower possible energy level first. So here we have to consider that the conditions, that is n plus L. So when the n plus L values are there, here n is principal quantum number, L is the azimuthal quantum number. So when we are having, say, n is equal to 1, then L is equal to 0. So when we begin with the electronic configuration or distribution of electrons in the n is equal to 1, we have to begin with the n is equal to 0. That is, we have to start with the s orbital first. So after filling this s orbital, we have to go for the next value. So that is, after n is equal to 1, it is 0. So when n is equal to 2, it is also 0. So we have to again go for this s orbital. That is, this is 1s, this is 2s. Then there is also, when n is equal to 1, there are these orbitals called 2p orbitals. When the n is equal to 3, we have to also go for, then first 0, that is 3s. Then again for 1, we have to go for 3p orbitals. Then for 2, that is 3d. So we observe that the energy of this orbital is lower than the next orbital. That is, we will consider their fourth domain n is equal to value, and these are L value. So for fourth mention, the L values are 0, that is 4s. Then there is L is equal to 1, where there is 4p. Then for L is equal to 2, there is 3d, and the L is equal to third, then it is 4f. So we have to see that the energy levels of this d orbital, energy level of this d orbital, and energy level of this 4, energy level of this 4s. Here we will see that energy of 4s is relatively closer or less than energy of 3d. So here we have to fill the energy level 4s first, and then we have to go for 3d. So instead of distributing electrons in 3d, we have to come back here to the 4s, and then we have to again go back to the 3d. So in this way we have to carry out the distribution. So we will see this in actual periodic table. So we know that the periodic table is showing the various blocks, that is, so you will find that are two columns, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. We will make it relatively smaller orbitals because it will fit accurately here. So we will take this a rectangular form. So here we will distribute these orbitals into n is equal to 1 up to 7. So this is for n is equal to 1, for n is equal to 2, for n is equal to 3, for n is equal to 4, for n is equal to 5, for n is equal to 6, for n is equal to 7. So this is n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, n is equal to 6, and n is equal to 7. Then we will divide this into 18 vertical columns. So this is first column, second column, third column, fourth column, this is fourth, fifth, sixth, seventh, eighth, 9, 10, 3, 4, 5, 6, 7, 8, 9, 10. This is 11, 12, 13, 14, 15, 16, 17, and 18. So this is our periodic table. So we will label these columns as number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. we know that when we take the hydrogen atom for the distribution, we will see that it will consider the electronic configuration. Hydrogen has only one electron, so that is it should go in first s orbital, that is 1s1. So we will show here the orbital used here. So we will label these orbitals as s block, s orbitals. Then there are 10 orbitals starting from this, that is d block. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So up to this is d orbital. Then from this to this there is p block. Then we will show that the hydrogen atom has only one electron, so that will move into 1s. So we will write here 1s. Then second element is helium 2He. So it has 2 electrons. So it should occupy this 1s with 2 electrons, because S is having capacity to occupy 2 electrons. So second electron will go into again 2s. That it should go here. But for our convenience, that in order to group the elements into elements of same characters, that is of same family, this element is placed here, that is 1s here. And the intermediate blocks are here, are removed. Intermediate places are removed here. So this is for our convenience, but it is expected to go here. Now the second element. So if we are having lithium with 3 electrons, 3 atomic number means 3 electrons. So first electron goes here, second electron goes here. Now the s orbital is completed. Then we have to go for third electron. So s orbital has completed its capacity. So it must go into next orbital, and that is the 2s. So here 2s begins. So it should go into 2s. Last electron will go into here. So first 2 electrons are present here in for this lithium. First 2 electrons are present in 1s, this 1s. Second electron will go into this 2s. So second electron, this last electron will enter into this 2s. So we will show here the next orbital filled here is 2s. Then this 2s next to it of same energy. So its s is completed. Then the next orbital is opening here for, we have seen just before that after 2s the next atomic orbital of the slightly higher energy is 2p. So it begins from this 13, 14, 15, 16, 17, etc. So here we will show that the 2p orbital, 2p, these are 2p orbitals should be filled first. 2p, then 2p. So 6, these 2p orbitals are filled progressively. So after filling the 6 orbitals are 3, but capacity to occupy electron is 6, and that is why we have shown the 6 places. So first electron of p orbital goes here, next here, next here, next here, next here, next here. So in this way 6 electrons are distributed and the capacity to occupy electrons of p subshell is completed. Next electron will move into this n is equal to 3, that is third main shell having orbital 3s. Next electron also goes with 3s. Then the next electron will also coming into this 3p, 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 3p. So in this way we have to show this 3p. So 3p is filled up completely. Now we have to remove this intermediate or unused blocks or space. Now we have this n is equal to 4 because the 3p is completely filled. Now we have to go here with 4s. So 4s will contain 1 electron. So next electron will go into this 4s. Again, now we have seen just a few minutes back that after 4s, the energy level of this 4p is much higher. But the energy level of 3d, so 3d begins here. 3d begins here. So next electron is coming into this 3d. So 3d is occupied. So there are 10 electrons occupying the space of d orbitals. So d orbitals will occupy this by electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 places means there are 10 electrons available for moving into d orbitals. There are 5 d orbitals. But every orbital has capacity to occupy 2 electrons. Means these 5 d orbitals can occupy maximum of 10 electrons. So we have shown this 3d 10 times. After completing the 3d, means there is no space for electron in the 3d. Now it goes to slightly higher energy level. That is, here it is 4p. Then 4p, 4p. So in this way 4p, 4p, 4p and 4p. So in this way the 4p orbital is also occupied. Now there is no more space in this 4p. So the next electron will go into this 5s. The 5s with second electron. So 5s with first electron, 5s with second electron. Then after completing this 5s, the next electron will go into again this 4d, because the energy level of 4d and 5s is nearly same. So 4d, 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 in this way 4d, 4d, 4d. So these 4d orbitals are progressively occupied. Now the 4d is completed, there is no more vacancy for any electron. If there is one more electron, it goes into this 5p, next into 5p, next into 5p, next into 5p, next into 5p. In this way 5p is filled or completed, and there is no more space in the 5p. The next electron will go into this 6s. 6s. So 6s will occupy maximum of 2 electrons. So after completing the capacity of 6s, the next electron move into this d orbital, that is 5d orbital. But here the 5d orbital is specific. So we have to use here another box, that is orbital. Like this. So we will divide this into 14 columns. So there are 14 boxes available for 14 electrons. Now the element which is coming after 5d means after entering this one orbital of 5d, the energy level of this 5d and energy level of this 4f. This is 4f and this is 5f. So here we have shown this. That is electron from next to this 5d will enter into this 4f. So we will show this as the 5d. After 5d it will begin with 4f. So these 4f will be filled first. 4f. 4f. So in this 14 electrons are distributed in the 4f. There are 7 f orbitals in the 4f or 5f. So they will occupy maximum of 14 electrons. So if we fill the 14 electrons here, there is no more space. Then the next electron will come here. So that will begin with the occupying this orbital. So we will show that it is 5d. Then again 5d. So in this way 5d will keep on filling. So 5d, so 5d. So after occupying these 5d orbitals, the capacity of D is completed. Now next electron will enter into this here 6p. So 6p will be filled here. 6p. So after 6p is completely filled, that is the capacity is fulfilled, then next electron will enter into this 7s. So we have to distribute the electron in 7s. So 2 electrons will enter into 7s. So after completing this 2s, next electron will go to 6d. Now it has also this specific structure, specific feature, that after distributing this electron in 6d, when electron goes into 6d, the energy level of 6d and this 5d F is also same. So electron prefers to enter into this 5f orbital. So we will show here 5f. So 5f is filled progressively. So 5f is filled progressively. So after 5f, the next electron goes into this D subshell, that is 6d. So 6d is progressively filled here. Then after completing the capacity of 6d, the next electron will enter into this p subshell, that is here 7p. 7p. So in this way, the electrons are progressively distributed. So again, the 7th p will be completed. So we have to go on distributing electrons in this order so that the correct distribution will be observed. And we have to consider here that the 5d is just a beginning here but second electron goes into this 4f, and 4f is completed first. After this, next electron goes into next atomic orbital of this 5d. So in this way 5d is filled, then again 6p is progressively filled. Similarly here in case of 6d, the one electron is moving here, and also because of this 6d and 5f are of same energy. So electron can move in this 6d and also here 5f. So 5f is progressively filled. So we have to remember this type of the rule that is given by this Schleskowsky rule. And so we will stop here our discussion, and we will continue the next point in the next lecture. So please subscribe to this channel. Please press the like button and bell icon button. Thank you very much for watching this channel.